with one more problem, Leetcode, and it is called palindrome partitioning. And in this problem, what it states is that we would be given a string and we have to extract the number of different palindromes that exists in the string. So every substring of that part of the partition is a palindrome, and likewise return all the also substrings. So let's first figure out with two examples, like with, let me just refresh this so that we can have a better, we can recreate it once more. Okay, let's recreate this example. Uh, let's say we have a string a, and b. What we need to do is that we have to look up for palindrome inside this string and keep that as a prefix. So let's say the first prefix is a. If a is a prefix, then the rest of the string we would need to have some more palindrome, and this same method would continue. So since one of this prefix will always be palindrome, so AAB, if I'm taking A and A is definitely palindrome, next time we would be taking AA. Is AA a palindrome? If yes, then we would be continuing. So let's see what I mean is that there is the string AAB. I extract A out of this string and I keep A, and what I'm left with is AB. Of this AB, I will extract A because A is obviously a palindrome, and I would be left with B. Of this B, I would again extract B because it is also already a palindrome, and I will be left with nothing. So till the point I am not left with anything, this whole set is a palindrome AAB. Now let's see what is the next thing that we can build, right? So we started off with index 0, A. So if I'm going to extract the next substring of 0, 1, that is AA, is it a palindrome? Right, it is a palindrome, right? So if we are going to extract AA, then what are we left with? B. And from B, we can only extract B, and we would be left with nothing. So the next set would be AA and B. So there would be two sets. One is AAB and the other is AA and B. Likewise, let's see, this example already had a palindrome preceding it, right? So let's see an example called CDD. Now with CDD, we would again start off from index 0 and extract the character that is C, and similarly proceed by creating a substring. And let's, as of now, stick to index 0 and we extract C and get DD, right? Now from DD, we again start from index 0 on this DD, and what we can extract is D, and we will be left with D. So from D, we can only extract D, and we will be left with nothing. Now this is one set, C, D, D, right? But we are not done yet. From DD, we are still at index 0, so we can go to index 1. So does index 0 and 1, this substring, is it a palindrome? Right? So we extract DD and we are left with nothing. So the other set that comes up is CDD. So there would be two, one CD, D, and C double D. Let's assume a palindrome like ABC, ABA, sorry. So if by itself it is a palindrome, we will again start off from A, and extracting A will give us BA, and from B we will again extract B. We will be left with A. From A we will extract A. We will be left with nothing. So one is ABA. Now let's see, does AB as a substring make any sense? It doesn't, right? So we proceed to the next step. Let's see if ABA makes sense. Yes, it is a palindrome, right? So we extract ABA and we are left with nothing. So two sets here would be ABA, and the other is the whole string ABA. So now that you understand the concept, it is like extracting the prefix and whatever the remaining is, pass it back to the same depth first search function and just repeat it. So let's put it into practice and let's create a result, because result of type list, because that's what we would be returning. And let's define a function called depth first search of is and the sub result, right? So what we need to do is that we need to extract character substring from s, right? So let's build a loop that would extract the characters or the substring from s. So prefix that we are extracting is s of I plus 1, right? So initially I would be 0, so it will extract the 0th character, and then initially I would be 2, then it would extract the 0 and 1 characters. So it is just substring. Now you have to check if this prefix is a palindrome, and we can check that easily, like um, is it a palindrome? Now if it is a palindrome, then the rest of the string has to be again sent back to the depth first search, right? So we are going to send back the rest of the string, that is from I plus 1 onwards, everything, and whatever the result is. So in this result array we have to append the prefix, and we have to remove the prefix. The reason we need to remove it is because let's say in this case uh, we have dd. How did it change color? We have dd, and from dd you extracted d. Now the result or the sub result array, the res that we are putting it, the res is nothing but this sub array. So once that has this d, you have to remove this d to add dd next time to c. So that is the reason every time we add, we have to maintain the result array, the state with which the function was called, and we just are removing it. Now time for the base function. And when are we going to stop is that when length of s is 0, we are not going to do anything more, and we are just going to append to the result array the sub result, right? And we have to call the function with s and a null, and what we can do is just return result, and that is all. Let's run it and see it in action. Sorry. Let's submit and see if everything is passed. So yeah, it seems our solution is intact. So that's all, guys. Thanks.